All right, so now we're going to take a look at some of the chemical reactions that the organic compounds, and specifically the hydrocarbons, are going to undergo. And there are many different types of reactions depending on the family of organic compounds. So we're just going to focus in on one of these, and it's a reaction type that we've seen previously. So these are going to be combustion reactions. And if you remember, we talked about combustion reactions before. This is simply the reaction of a carbon-containing compound with oxygen, so O2, and then we end up making carbon dioxide, and then we also get water vapor as the other product. So as a specific example of this, if you have something like we do methane, which is one of the alkenes we looked at before. So methane, undergoing combustion, methane is CH4, can react with O2, and we end up making carbon dioxide, and then we get H2O, water vapor as a product. We need to balance our equations. We need a 2 here and a 2 there. And then the main reason for these types of reactions is that we also get a bunch of energy being produced, right? So this releases energy. These combustion reactions, they release energy. So as a result, these alkanes, these hydrocarbons in general, are used as fuels, especially the smaller ones, smaller HCs. So you can think about the gasoline in your car as a fuel. That's a mixture of all different types of alkenes, like different types of octane and other things in there. And the reason why is because they undergo this combustion reaction very easily to produce a bunch of energy that we can harness to perform all sorts of tasks and work for us. So this is going to be the main type of reaction, chemical reaction, combustion reactions. Now, we also looked at combustion reactions before, and we said that in the absence of oxygen or sufficient oxygen, then what we also get is incomplete combustion. And that also produces carbon monoxide, CO, which is poisonous, right? So depending on what situation you're in or how much oxygen you have available, the products can be slightly different. Now, the other thing to note is different types of hydrocarbons will burn slightly differently as well. So generally, what we're going to see is that small hydrocarbons and your alcohols can burn cleanly, say, with a clean flame. Okay, so there's complete combustion, in other words. So if I have something like methanol, for instance, so methanol is CH3, OH reacting with oxygen. Again, we'll get some CO2 and we'll get H2O. And we'll need to balance our equation. So this is unbalanced. You can practice balancing your equation if you wanted to. When we have aromatic hydrocarbons, for instance, right, these typically burn with a dirty flame. In other words, you'll see soot being produced, or a sooty flame, in other words, so black sort of particulates coming off, and that's an indication then that there's incomplete combustion just due to the type of hydrocarbon that we're dealing with. All right, so obviously you probably wouldn't want to burn that and as used as a fuel because you're not really getting a lot of energy out for the same amount of fuel that you're using compared to some of the other ones. But that's one way we can sort of tell the difference between sort of an aromatic hydrocarbon and one that's not, the smaller hydrocarbons, alcohols, tend to be a little bit cleaner in terms of how they burn the products that are produced in each case.